Good day, everyone. My name is Vladislav Korzun. I am a PhD student at MyPT, and today I present you a winning solution for Russian relation extraction for business task within Dialog Evaluation 2020. First of all, let us recall the shared tasks. The whole competition consisted of 3 subtasks: named entity recognition, a relationship extraction with named entities, and end-to-end relationship extraction. Here we present solutions for the first 2 problems. So, in near task, the objective is to provide entity spans in a text and classify them. In area task, we should detect the relations between entities and provide its labels. So, in a given example, on the slide, you can see 5 entities marked as from T1 to T5 of 4 different classes, and one relation marked as R1. To solve these problems, competition organizers provided a manually annotated corpus of Russian business documents. Let's take an overview of this corpus. In a table, you can see a general statistical information. For sentence segmentation, we used NLTK package. In a diagram, sentences length distribution is shown. As you can see, there are a lot of long sentences with length more than 120. And that brings a lot of problems for training transformer models like BERT. However, most of such sentences are enumerations, and we can split them to make their length appropriate for the training such models. Here you can see an entity distribution by classes. So, the classes are a little unbalanced, and there is a difference between distribution on the test and on the train. Now let's take a look on a relation distribution. Interestingly, any pair of entity classes is possible. Therefore, we couldn't manually filter possible relations by entities classes. So, let me describe our solution for near task. First, we used an LSTM-based approach. We tried different features like fast text word embeddings, character embeddings, casing patterns, and post tags. As a model, we used an 2-layer bidirectional LSTM followed by self-attention. Model dimensions and results of adding different features are shown in the tables on the slide. Then we switched to a BERT-based approach. We tried different configurations like freezing BERT parameters using different pre-trained BERTs and different classifiers over BERT outputs. As a result, R-BERT with simple linear layer as a classifier outperformed LSTM-based approach, but didn't get a state-of-the-art result. These results were also obtained after competition ended. So, let's switch to our solution for the second task. To solve this problem, we reduced it to relationship classification task like SIM-eval 2010 task 8 by sampling sentences for each pair of entities. But if we take all possible pairs of entities for each sentence, the train epoch will be too long. So we decided to reduce amount of negative samples by taking random pairs of entities in amount not exceeding the doubled number of positive ones. So for this sentence on the slide, we have one positive sample from markup, and for each train epoch, we take maximum 2 of possible negative samples. However, for inference, we take all possible pairs. To solve the relationship classification problem, we tried 2 models. In the first approach, we just concatenated BERT outputs with near embeddings and passed obtained vector through self-attention, averaging the entire sequence. The second approach is R-BERT, which have one of the best results in SimEval task 8. The main idea is inserting special tokens between and after entities to a BERT input. Then, the outputs corresponding to CLS token and entities are averaging and concatenating, as shown on the picture. As a result, R-BERT outperforms previous model, which has a poor result, and R-BERT also took the first place in considered track. So, that brings me to the end of my report. Thank you for your attention. The code solving considered problem is available in a GitHub by link below. And the original R-BERT paper is also worth mentioning. Have a nice day.